Now we're going to look at multiplying and dividing fractions. Let's start with 4 times 1/3. That means 4 lots of 1/3. So there I have 4 lots of 1/3. So I've got 1/3 plus 1/3 plus 1/3 plus another third, and I've got a total of 4/3, or if I put them as a mixed fraction, that's 1 and 1/3. And that's exactly the same as our usual multiplication. If we have 4 times 5, for example, that means I've got 5, add 5, add 5, add 5, which gives me 20. Fractions work in exactly the same way. So if I had 2 times 1/5, I'd have 1/5 plus 1/5, giving me 2/5. Now, multiplication is commutative. I'll just write that word down, commutative. Now that means in our normal multiplication that 4 times 5 is exactly the same as 5 times 4. Our 4 times 5 was 5 plus 5 plus 5 plus 5. And our 5 times 4, our 5 lots of 4, is 4 plus 4 plus 4 plus 4 plus 4. So we have 4 5 times. And they are exactly the same, giving us 20. So it doesn't matter whether I write 4 times 5 or 5 times 4, because multiplication is commutative. Well, let's see what that means when we're looking at fractions. Let's say I have 6 times 1/3. Multiplication is commutative, so that says it should be the same as 1/3 times 6. Let's have a look what that means. 6 times 1/3. 1, 2, 3, 4, 5, 6. So there's our 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. And this side, I've got 1/3 of 6. So let's take 6. 1, 2, 3, 4, 5, 6. And I want 1/3 of that 6. So it's like sharing it out between 3 people. There's one person's, another, and another. I want 1/3, so I'll just remove the other 2/3. So my 1/3 of 6 is just like doing 6 divided by 3, and that gives us an answer of 2. Well, what's my 1/3, add 1/3, add 1/3, and add the others together, and there I have 2. So here, 1, 2, 3, 4, 5, I get 6/3, which gives me 2. So I've shown that with fractions, it's exactly the same. It's commutative, and that's what it looks like. But with fractions, you can see it in the 2 different ways. Either a fraction of a whole number, like we had here, or a fraction taken a whole number of times, like we had here. Let's move those out of the way. Let's look at another example. 5 lots of 2/3. So we've got 2/3 5 times. So what we have here is 2 plus 2 plus 2 plus 2 plus 2, or actually 5 times 2 thirds. So we've got 10 thirds. And 10 thirds, if we write it as a mixed fraction, is 3 whole ones, as 3 threes are 9, and 1/3 left over. Now, any number can be written as a fraction. For example, the number 2 can be written as 2 over 1, 4 over 2, 6 over 3, and so on. So we can write a whole number with a denominator. So it's a numerator and a denominator, and these are all equivalent fractions to that 2 over 1. So another example, 2 times 3/4, we can write as 2 over 1. So we've made our whole number into a fraction times 3/4. So what we have here is 2 times 3 and 1 times 4. So 2 3s giving us 6, and once 4, 4. And if we put this as a fraction in its lowest form, then we divide both the numerator and the denominator by 2, so we get 3 over 2, or as a mixed fraction, 1.5. Let's have a look at another example. This time 7 multiplied by 5/9. So let's turn our 7 into an equivalent fraction with 1 as the denominator, multiplied by 5/9. So we've got 7 times 5 over 1 times 9. So we have 35 over 9, or as a mixed number, that's 3 8/9. Now let's have a look at an example where we're finding a fraction multiplied by another fraction. So let's take 1/3 times 1/2. And this means we want to take 1/3 of a half. So there's a half, and we want to split it up into 3 equal pieces. But let's look numerically, what we were doing before, multiplying the numerators and multiplying the denominators. So 1 times 1 is 1, and 3 times 2 is 6. So we get an answer of 1/6. Well, let's have a look. If we put some 6 on here, we can see that 3/6 is the same as a half. So if we split a half into 3 equal-sized pieces, and we want 1/3, we want one of those pieces, then we get 1/6. Let's look at another example. Let's do 1/3 times 2/5. So this time we want 1/3 of 2/5. So there's 2/5, and we want to split it into 3 equally sized pieces. Let's have a look again numerically, and then look to see what we get visually. So 1 times 2, we multiply the numerators. 3 times 5, we multiply the denominators. Once 2 is 2, 3/5 of 15. So the answer is 2/15. Well, how does that come about? Well, instead of trying to split those 2/5 into 3 pieces, it's actually much easier to imagine it as splitting 1/5 into 3 pieces, the other 5th into 3 pieces, and then taking one section from each. If we split a 5th into 3 pieces, instead of 5 pieces making our whole one, we'll actually have 15 pieces making our whole one, because there'll be 3 pieces from each of the 5ths. So that's where our 15th comes from. And then we take one of the 3 pieces from this 5th and one of the 3 pieces from this 5th, which gets us our 2/15. Let's do a few more examples. Let's say we have 2/5 times 4/9. So what we're doing each time is we're multiplying the numerators together and we're multiplying the denominators together. 2 4s are 8, 5 9s are 45. So we have 8/45. And another one, 2/3 multiplied by 4/5. So we've got 2 times 4 divided by 3 times 5. 2 4s are 8, 3 5s are 15. So we have 8/15. Now, if we just think about what we've been doing here, we've been taking a fraction of another fraction. And because the fractions we've been dealing with are proper fractions, they're less than 1, so 2/3 is less than 1, we're taking 2/3 of 4/5, then we expect an answer that's smaller because we're taking a fraction of the 4/5 or a fraction of the 4/9. So in all these cases, we have an answer which is actually smaller than the fraction we started with, which is what we expect, because we're taking a fraction, a smaller fraction of it. Let's do another example. This time, let's have 2/3 multiplied by 9/10. So we have 2 times 9 divided by 3 times 10. 2 9s are 18, 3 10s are 30. Now we need to realise that this is not a fraction in its lowest form, so we would need to find the lowest form. They're both even numbers, so we can divide both numerator and denominator by 2 and get 9/15. But let's just look back at this stage. If I write it out again, and we could have avoided that, because what we can do is some cancelling before we actually do the calculation. We can see we've got a 9 here and a 3 here, so we can divide both the numerator and the denominator by 3. When we divide the numerator by 3, 3 3s are 9, goes 3 times. When we divide the denominator by 3, it goes once. And if we look further, we can see that we can also divide by 2. 2 goes into 2 once, and 2 goes into 10 5 times. So this is actually 1 times 3 divided by 1 times 5, and we get 3/5. And in fact, you can see here that I didn't look closely enough and divide, in fact, by 3. It's easy to miss. So if you can make it easier for yourself and do some cancelling, then you should do so. So we end up with 3/5. Let's look at one more, this time involving 3 fractions. So let's have a half multiplied by 3/4 multiplied by 2/3. Exactly the same process as before. We're multiplying fractions, so we multiply their numerators. Doesn't matter how many there are. So it's 1 times 3 times 2. And we multiply their denominators. So that's 2 times 4 times 3. Now, before we go any further, let's have a look if there's anything we can cancel. Well, yes, we've got 2 goes into 2 once, 2 goes into 2 once. We can divide by 3. So we end up with 1 times 1 times 1 at the top. That's 1. And 1 times 4 times 1, just giving us an answer of 1/4. Okay, so what happens when we have mixed fractions and we want to multiply them? Well, let's have a look at some examples. We've got 2 1/3 multiplied by 3/4. Well, what we need to do is to turn this mixed fraction into an improper fraction, because when we've done that, we can simply do what we've already been doing, multiply the numerators, multiply the denominators. So here we need to turn our 2 whole ones into thirds. So it needs to go over 3. So 2 whole ones times by 3, then add this one here, and that's how many thirds we have, multiplied by 3/4. 2 3s are 6, plus 1, so that's 7 thirds times 3/4. 3 goes into 3 once and into 3 once. So having cancelled, we end up with 7/4, or 1 3/4. One more example. 1 2/5 multiplied by 2 5/6. Again, mixed fractions need to be turned into improper fractions. So here we have 1 multiplied by 5, because that tells us how many fifths we have with our whole one, 5 of them, plus the 2, that's our total number of fifths, multiplied by, we need the 2 whole ones in terms of sixths, so that's 2 lots of 6, plus the 5, and that's our number of sixths. Once 5 is 5, plus 2 is 7, so that's 7/5, multiplied by 2 6s are 12, plus the 5 is 17, divided by 6. Quick check. No, there's nothing we can cancel there. So 7 times 17, 7 10s are 70, 7 7s are 49, so that's 119. 6 5s are 30, so that's 119th 30th. And we had mixed fractions to start with, so let's turn this back into mixed fractions. Well, 3 30s are 90, so that's 3 whole ones and 29 30ths left over. So to multiply fractions, you multiply the numerators together and you multiply the denominators together. If you start with a mixed fraction, you need to turn it to an improper fraction first before you do the multiplication. Let's go on to division. 1/4 divided by 2. Let's have a look at 1/4. We want to split it up into 2 pieces. So 2 equal pieces. Well, 2 equal pieces, there's 2 equal pieces fitting on top. Each one is 1/8. So we split it in half and we've got 8s. If you can imagine our whole one and we had 4/4, if we have 8s, we have 8 pieces, each one is an 1/8, so 2/8 fit into a quarter. So a quarter divided into 2 bits gives us 1/8. Now, dividing by 2 is the same as multiplying by a half. So a quarter divided by 2 is equal to the same as a quarter multiplied by a half. And we're back to multiplying fractions, where it's 1 times 1 at the top and 4 times 2, giving us our eighths. So this statement here is exactly the same as this one here, because dividing by 2 is the same as multiplying by a half. Let's have a look at another example. A third this time, divided by 4. So we want to split our third into 4 pieces. Well, dividing by 4 is the same as multiplying by a quarter. So what we have is 1 times 1 for the numerator and 3 times 4, which is 12, for the denominator. So a third split into 4 pieces gives us a 12th. And again, if you think of each of these thirds being split into 4 pieces, we've got 4 there, 4 there, and 4 there. So our whole is 12 pieces. And we've taken one of them because we wanted 1/3 divided by a quarter, divided into 4 bits. So we take one of them, so we've got a 12th. Let's do a half divided by 2. Back to an easier one to see. There's our half, split it in 2, and we all know what we get. Well, let's do it. Our divide by 2 is the same as multiplying by a half. A half times a half, 1 times 1 is 1, 2 2s are 4, a quarter, which is exactly what we expected. Cut a half in 2, and you get a quarter. Now, as we can write any whole number as a fraction, I could write this as a half divided by 2 over 1. And then what's happening here is what I'm doing when I multiply is I'm turning this upside down. So to divide fractions, what you do is you take the divisor, the one that's doing the dividing, and you turn it upside down and you multiply. Let's do some more examples. Let's do a half divided by a quarter. So we have a half, we take the divisor, we turn it upside down, and instead of dividing, we multiply. So what we have here is 1 times 4 over 2 times 1, which is 2, so we end up with 2. So a half divided by a quarter. Well, let's just look at that. That's a half, and that's saying how many times does a quarter fit into a half? Well, we know that our quarter fits into our half 2 times. And that's the answer we had. A third divided by a fifth this time. So we've got a third, and we take the divisor, we turn it upside down, and we multiply. So we end up with 5/3, or 1 2/3. So what we're saying is we've got a third. How many fifths fit into a third? Well, there's our fifth. Well, we can see that it goes 1 whole one and part left over. It doesn't go as much as twice, it's part left over. So there's our answer, 1 2/3. So it goes a whole time and 2/3. Let's look at a whole number now, divided by a fraction. So let's look at 2 divided by 1/8. So we're saying we've got 2 whole ones, and we want to know how many eighths fit into the 2 whole ones. Well, if we think about it, we know that there are 8 eighths in a whole one. So if we've got 2 whole ones, there must be 16 eighths. So we know our answer is 16. Well, let's see what that looks like if we use our rule. So we take our 2. The divisor is our eighth, so we turn it upside down and we multiply. And yeah, we've got 2 eighths of 16 divided by 1, and we get our 16. Let's do 4 divided by a third. So how many thirds fit into 4 whole ones? We know that there are 3 thirds in each whole one, and we've got 4 of them. So we're going to end up with an answer of 12. But again, let's look at that using our method here. We multiply and we turn the divisor upside down. So yes, we get 12. Now, so far with our division, we've only looked at fractions with numerators of 1. Let's now look at some others. Let's say we've got 3/4 divided by 2. Same method, 3/4. We can write the whole one as a fraction, so it's 2/1. To divide, we turn the divisor upside down and we multiply. So we have 3 times 1 is 3, over 2 4s are 8. So we have an answer of 3/8. And if we think about it, if you visualise 3/4 and splitting it in half, quarters split in half are eighths. 3/4 split in half will be 3/8. 3/5 this time, divided by 4. So we're taking 3/5, splitting it up into 4 pieces. What do we end up with? 3/5. We're going to divide by, let's put it as a fraction, 4/1. Turn the divisor upside down and multiply. So we have 3 times 1 is 3, over 4 5s are 20ths. One more example. 2/3 divided by 3/4. What we're looking at here, there's our 2/3, and we want to know, there's 3/4. How many times 3/4 fits into 2/3? Well, you can see it doesn't go a whole one. So we can expect our answer to be less than 1, because 3/4 is actually bigger than 2/3. Well, let's have a look. 2/3, turn the divisor upside down and multiply. So we have 2 4s are 8 and 3 3s are 9. So we get 8/9. 9/9 are a whole one, so it's just under a whole one, which is what we can see when we look at it visually, how many times this fits into this. Finally, how do we deal with mixed fractions? Well, let's have a look at an example. We've got 1 2/3 divided by 2 1/4. And it's exactly the same as we did before. We must turn mixed fractions into improper fractions before we do the division. So 1 2/3 is 1 lot of 3 plus 2/3 divided by 2 1/4. Turn the 2 whole ones into quarters, so that's 2 times 4. Add the 1/4. That's how many quarters we've got. Once 3 is 3, plus 2 is 5/3, divided by 2 4s are 8, plus 1 is 9/4. To divide, we turn the divisor upside down and we multiply. So that becomes multiplied by 4/9. Can we do any cancelling? No, we can't. 4 5s are 20, 3 9s, 27. So we have an answer of 20/27. And another example, 2 4/5 divided by 4 2/3. We need to turn these into improper fractions. So we've got 2 lots of 5, that's the whole ones turned into fifths, plus the 4, that's how many fifths we've got, divided by 4 whole ones, we need them turned into thirds, so that's 4 times 3, plus the 2, that's how many thirds. 2 5s are 10, plus 4 is 14 fifths, divided by 3 4s are 12, plus 2 is 14 thirds. To divide fractions, you turn the divisor upside down and you multiply. Check for anything that's common to both, so we can divide through here by 14. That saves a lot of calculation. And we end up with once 3 is 3 at the top, 5 1s 5, so an answer of 3/5.